Given you hopefully a few different situations so you can apply this idea. I think some of you are going to have success with this by knowing the formula, being able to use that to find this out, to figure this out. It says you're flipping a coin 4 times. Is the result of each flip, is the probability the same each time? They're independent, right? So independent. Okay, there's a check mark. Each trial's the same. It's all good. It's all good, right? It works. There's only 2 outcomes. This only works if there's 2 outcomes, like success and failure. You need, if you know the probability for one, the other is the complement of that. There's only 2 outcomes here, right? If we want exactly 4 to figure out what's the chance you're going to get 4 heads on 4 flips, you wouldn't really need this because a lot of you would just say, well, it's this, so it's 1/2 times 1/2 times 1/2 times 1/2, right? You don't really need the binomial theorem. Some of you might even write it's 1/2 to the 4th. But the binomial theorem is going to say, you could have the other part here and say, what's the probability of failure here for the non-heads or the tails? 1/2 to the 0, right? And you really could say from the 4 flips, choose 4 of them to be the successes. In this particular case, there's only one way, so you don't really need this idea. And it's only that thing in the middle. Well, because there's none of them there, right? This one is exactly 2. Well, if you want the actual number here, it's 1 out of 216. If you want the second one here, not 216, what I'm talking about, 16. Still stuck on my 6s on the bottom. 2 out of 4. There's more than one way this can happen, right? You can get the 2 heads first and then the 2 non-heads, which are obviously not called non-heads, they're called tails. And you call heads or you call non-heads. Or it could be this, obviously, right? There's a bunch of different ways. There's not tons, but there's a bunch. There's 4C2, or in other words, 6. And then what's the other part of it here? I need to pick one of the ways, like this one, right? If it was heads, heads, tails, tails, I need the 1/2s for this. 1/2 to the power of 2, and I need 1/2 to the power of 2. Now I know some of you are saying, why can't you just call that? What can I call that?
You want a wrong answer right now?
No. Well, in this particular case, we could write this as something simpler because you could write it as 1/2 to the 4th in this case because success and failure are 50-50. It's the same, right? But we're leaving it like this because it'll get you confused for things where it's not 50-50 chance. So it's 6 times 1/2 squared, 1/2 squared. I would do this as, I would just figure out the bottom number 16 and multiply all the top numbers. 6 times 1 squared times 1 squared. So this is 6. I think more of you have trouble if you try to do on your calculator 1/2 squared times 1/2 squared times 6. It's better if you want, because this way you can leave it as a fraction too. If the numbers are really big, it won't change it into a fraction on your calculator. You can always give it as a decimal. It doesn't matter. At least 3 heads. Yeah, this we have to think of as, what does that mean?
It means there could be zeros.
No, at least 3. 3 heads, 1 tail, or 4 heads. You can put in 0 tails too if you want. Except that looks like 3 hit or 4 hot, but that's what it is. Okay? What's the probability for each of those? Can we do one of these calculations for this all together? Well, is the probability for, I even forget what this means now. 3 hits, 1. This is a 1, right? Not hit. For this, is the probability for this the same as the probability for that? Like, can I just say there's how many ways are there to get 3 heads and 1 tail?
3 head, 1 tail.
Well, there's from the 4 flips, I got to choose 3 to be the successes, right? And then you need a half to the third, and you need a half to the 1, right? For the 1 tail. Plus, we got to do 4C4, a half to the 4th, a half to the 0. Please don't think you have to put in this. To the 0 doesn't need to be there. We're just putting it in for the sake of putting it in. And the same with this. You don't need to count how many ways there, right? This is like 4 times, all of that ends up being 1/16th, right? This is like 1 times 1/16th. The whole thing all together, you got 4/16 plus 1/16, you have 5/16. You're adding 2 cases together. If we were doing this 12 times, you could still figure this out. I want you to look ahead here, and I perhaps gave you a question which is quite a few here. Exactly 6 out of 12, you can write an expression and figure it out. Exactly 2. Give me a question that would be a lot of work here that we could add in and then cross out. Let's write it out and then cross it out because it's too hard. Probability of...
Exactly 123 heads.
No, that would be just as easy, except the numbers are bigger.
Oh, okay.
At least 1's actually easy as well. At least 5. Why is at least 5 hard? What would you have to do? At least 5 means you have to do 5, 6. Okay. I am going to show you a shortcut on your calculator that'll do all of them together. But it's important that you know what you're doing first. Okay? I want you to calculate this, and then write an expression for that. And then try those questions. And then after that, we're going to look at the calculator function. Okay? All I mean here is write an expression for it. I am going to stop this and then I'll show you the calculator function.